All right, today we're going to be looking at lesson 6.2, properties of rational exponents and radicals. Remember, a rational exponent, a rational number, is a number that can be written as a over b. So basically we're looking at exponents that are fractions. All right, we're going to start with task 1. Investigate the properties of rational exponents. You previously used properties to simplify and evaluate expressions with integer exponents. Some examples are shown. All right, so when you have the same base and you're multiplying, you add exponents. When you have the same base and you're dividing, you subtract your exponents. And when you have a power raised to another power, you multiply your exponents. And when you have two things in parentheses, both of those would be to that power. Okay, so 3 squared and should be 3 squared and 4 squared. Not sure exactly what they did right there. All right, so here we have in parentheses squared, so the numerator should be squared and the denominator should be squared. All right, it says click to reveal general rules that appear. All right, so this is just used with the variables. Again, same base when you're multiplying, you add. Same base when you divide, you subtract. A power to a power, you multiply. A quantity raised to a power means each thing is raised. You kind of distribute that power. And a quotient to a power, everything inside the parentheses again gets raised to that power. So those are your general rules. All right, it says apply one of the general rules to each expression on the left to help you simplify one of the results on the right. All right, so these are now, we're using rational exponents. So that means they are fractions, but the rules are still the same. So here my base is 81. Same base when I multiply, I add exponents. So down here, I'm adding exponents. Here I have the same base, so I divide, or same base when dividing, so I subtract my exponents. Here I have a power raised to another power, so I'm going to multiply my powers. And here I have a quantity raised to a power, so I kind of distribute that power to both of those. So I'm going to have 81 to the 3/4 and 16 to the 3/4. And then I have a quotient raised to a power, so the numerator and denominator both get raised to that power. Okay, so just looking at the general rules. All right, it says show that 81 to the 1/2 power times 81 to the 3/4 power and 81 to the 5/4 power have the same value when simplified. All right, so 81 to the 1/2 power, that's the same thing as the square root of 81. So the square root of 81 is just 9. All right, 81 to the 3/4 power, if I think of 81 broken down, 81, let's see if I can get my pen to write here. All right, so 81 equals 9 times 9, and that equals 3 times 3 times 3 times 3. So in my head, 3/4 of that, 3 times 3 times 3, is just 27. So you can use your calculator to figure this out, but I just kind of like to see if you can like play these out in your head. So 9 times, let's see, same base, add exponents. So that's going to be 243. Let's make sure. Pretty sure that's right. Let's see. All right, so I'm going to do 9 times 27. 243. All right. All right, now we need to do 81 to the 5/4 power. All right, so let's do that on here as well. So I'm going to do 81 raised to the 5/4 power And that's going to be 243 as well. Oh, they just want us to rewrite it in radical form. Okay, so remember the denominator becomes the index, and the number on top is the power. Three to the fifth power. Pretty sure. 243. Good. All right, so that checks out. All right, based on your results from part B, predict the rule for the product of power property for rational exponents. All right, so you got the same base. Same base when you're multiplying, you add exponents. So same base, so we got m plus r and n plus t. Does your work in part B prove the product of powers property for rational exponents? If not, what must be done to prove the property? All right, so they want to know if it proves that this is equivalent to that. So we did prove that in this case. So if you could just prove that with variables, then you could prove that with for any case in general. So this does work. If you have the same base, when you're multiplying, you add exponents. Remember, when you add exponents, when it's a fraction, you have to get a common denominator. So this would be 2 over 4, and that's where the 5 over 4 comes from. Okay, if you have any questions, please let me know. All right, this is 6.2, lesson 6.2, task 2. Still looking at properties of rational exponents and radicals. All right, simplify expressions involving rational exponents. All right, so it gives you the properties here. We've seen these in task 1, but we've also seen these in math 2. So remember the product of powers, the quotient, the power property, a power to a power, and power of a quotient. These are all things that you should be able to work with from memory. Okay? All right, let's see what number 2 says. All right, simplify the expression. 25 is the same base, so I'm going to subtract from top to bottom. So you subtract 5 halves minus 6 halves, and that gives me 25 to the negative 1 half. All right, so what property justifies rewriting same base and subtract from top to bottom? So if you look up here above, okay, this is the quotient property. And may need to put quotient of powers property. Let's see. All right, so the quotient of powers, the quotient property justifies rewriting the expression. All right, what justifies rewriting 25 to the negative 1 half? All right, here you have a negative exponent. So a negative exponent is the same as a negative power. So the negative power tells you that you can rewrite that as 1 over 25 to the positive 1 half power. All right, what are the steps for simplifying the expression? All right, you got a same base quotient, so it means you're dividing. So you subtract from top to bottom. So subtract the numerators, keep the denominator. So 7 minus 2 is 5. 5 over 5 is just 1. So this would just be y, or y to the first power. The next one, what are the steps for simplifying the expression? Same base, you're multiplying, so you add exponents. In this case, you would have to get a common denominator. That would be 4. So this would be 2 over 4. 2 over 4 plus 3 over 4 is 5 over 4. So the answer to that one would be x to the 5/4 power. If you have any questions, please let me know. All right, lesson 6.2, task 3. All right, simplify expressions involving rational exponents. So you can apply multiple properties of rational exponents when simplifying an expression. All right, so it shows you how that you can go through. Shows you that you're going to take a power to a power. So here a power to a power. And then that equals, looks like they just rewritten it. They have rewritten it to where they move the y to the -1/2 to the top here. Okay. All right, so they're just using their properties of exponents to solve this. All right, then you get the same base up here, same base. That means you add your exponents. And then here you've got a power to a power, so you're going to multiply those. And because that's in parentheses, the 8 also gets raised to the 2/3 power. Okay, so here it just looks like they've just evaluated a power to a power. They put those together to multiply those. And then 8 to the 2/3, so that would be 1/4. And then y here, combine these, you have to do multiplication on top and bottom, so it'd be 10/12, and 10/12 reduces to 5/6. All right, match each property with the rewritten expression that it justifies. All right, so for part A, it says, okay, there's just a 3 of them there. All right, for part A, so what happens when it goes from here to here? And then I guess B is going from here to here. And then C is going from here to here. So which property are we using? A power of a power, a product of a power, or a power of a quotient? All right, so we can see that this one is obviously going to be the quotient one because it's taken the exponent to both the top and the bottom. So that's the power of a quotient. And then this one's a power to a power because they are multiplying the powers here. And this one, same base, they're adding exponents here. So that is a product of powers. All right, what are the steps for simplifying the expression? 36x to the 4/5 raised to the 3/2 power. All right, choose the justification for each step and the simplification. All right, so we have this all in parentheses raised to this power, so then they take the power to both of those. So that is a power of a product. And then this one, because they have 4/5 raised to 3/2, that's a power of a power. All right, and then from here, they've just used, they just simplified the expression. Okay. All right, so from here to here, they just multiplied across and then reduced it like we did in the last one. All right, that's all for task 3. If you have any questions, please let me know.